Today we're going to look at chapter 9.7, looking at probability. Again, this is something that is very useful if you're going to plan on taking stats next year. But even if you're not planning on taking stats, this is good information to know because it does have a lot of real world applications, whether it's flipping a coin or rolling a die or playing cards or picking a marble out of a jar. All of these have to do with probability. If you shuffle a pack of cards properly, chances are that exact order has never been seen before in the whole history of the universe. In fact, the chances of that happening are astronomical based on the number of cards. What is probability? Probability of an event occurring is a measure of the proportion of time that the event will occur in the long run. So what does that mean? So let's find the probability of an event. Suppose that in n trials, an event E occurs m times. The relative frequency of the event E is m divided by n. If the relative frequency approaches some value p of E as n becomes larger, then P of E is called the empirical probability of E. And I know that's a lot of words, but it really is quite intuitive once you start thinking about it. Now, first thing we have to define is sample space of simple events. So a simple event just means one thing happening. So the sample space is a list of all possible outcomes. So if you're going to roll a die, the possible outcomes, well, you could get a 1, 2, 3, 4, 5, or a 6. If you're going to toss a coin, your possible outcomes are either a heads or a tails. Now, if you toss two coins at the same time, what are your possibilities? Well, you could have two heads. You could have a head on one and a tail on the other. Or you could have two tails, or you could have a tail on the first and a head on the second. So those are what's called a sample space, your possible outcomes. So let's go over to the in-class practice and take a look at number 1 through 4. So a card is selected at random from a 52 card deck and its suit hearts H, diamonds D, spades S, or clubs C is recorded. What is the sample space? Well, what are the four possible outcomes? Hearts, diamonds, spades, or club. That's all you can get if you draw from a deck of cards. There's no other possible suit that you could get. Now, as part of a quality control procedure, 8 circuit boards are checked and the number of defects is recorded. Well, what's the possible outcomes? 0 could be defective, 1 could be defective, 2 of them could be defective, 3 of them, all the way up to all 8 of them are defective. So the number of defective boards is somewhere between 0 and 8. All right, this is a little trickier. Data concerning durable goods orders are obtained each month by an economist. A record is kept for a 1-year period of any increase, decrease, or unchanged movement in the number of durable goods orders for each month compared with the number of such orders in the same month in the previous year. So what are the possible outcomes? Well, there happen to be 36 possible outcomes. So the first month could be an increase, or if we took a sample, the first order month could be a decrease, or the first month could be unchanged. Same thing with the second month. It could be an increase, second month could be a decrease, second month could be unchanged. All the way up to the 12th month, which could be an increase, 12th month could be a decrease, or 12th month could be unchanged. So if we just take a random month and see what the possible movement is, these are the 36 possible possibilities that we would have drawing 1 month from random. Oh, I forgot to do number 4. Let's go back to number 4. So a meteorologist preparing a weather map classifies the expected average temperature in each of the 5 neighboring states for the upcoming week as follows. A would be more than 10 degrees below average. B would be normal to 10 below average. C would be higher than normal to 10 degrees above average. And D would be more than 10 degrees above average. So there's 4 possibilities of temperature moves, and there's 5 different states. So for the first state, it could be one of these 4 categories, A, B, C, or D. For the second state, it could be A, B, C, or D, all the way up to the 5th state, A, B, C, or D. So there's 20 possible different outcomes depending on which state he's looking at and depending on the temperature movement. So my sample space are these 20 different possibilities. And now let's go back to the slides. All right, so extremes of probability. The probability of a certainty is 1. Also could be, we could represent that as 100%. Now, the probability of flipping a nickel and getting a heads or a tails is 1. You're going to get a heads or a tails. It's going to happen. It's a certainty. So it's 1. The probability of rolling a 6-sided die and rolling either a 1, 2, 3, 4, 5, or 6, it's definitely 1. You're going to get one of those possible outcomes. The probability of an impossibility is 0, means it absolutely cannot happen. The probability of drawing a card from the standard deck of cards and getting a red club, assuming that you have a normal deck of cards, is 0. The probability of rolling a die and getting an even number and a 3 is 0. You can't get, if you roll a 3, it's not going to be even. It cannot happen. So what does this mean? It means probability is going to be somewhere between 0 and 1. Okay? 0 is the lower limit, meaning it cannot happen, 0%, all the way up to 100%. It absolutely will happen. And most of them are going to fall somewhere in between. So an experiment consists of spinning the hand on the disc below 1 time. Assume each outcome is equally likely. So find the probability of 3 and find the probability of 3 or 2. My sample space, it's going to land on 1, 2, or 3. Assume that there's no liners there. So the probability of landing on 3 is going to be 1/3. 1/3 of the time it's going to land on 3. Probability 2 is 1/3. Probability of 1 is 1/3. The probability of 3 union 2 means it's going to be either a 3 or a 2 is going to be 2/3, just simply adding them together. All right, here's a standard deck of cards. Consists of 4 suits: spades, clubs, hearts, diamonds. 2 of the suits are red, 2 of the suits are black. Each suit has 13 cards. It's okay, 2 through 10, a jack, queen, king, and ace. Jack, queen, and king are called face cards. So you're going to see a lot of questions that deal with cards. So probability in cards, find the probability for the experiment of drawing a card at random from a standard deck of 52 playing cards, and the card is a diamond. Well, that probability is going to be 13 out of 52. There's 52 total cards, 13 of them are diamonds, so there's going to be, we'll reduce that to 1/4. So there's 13 diamonds divided by 52 total cards. We always reduce fractions when we're talking about probability. If we wanted to, we could change that to a decimal, 0.25, or a percentage, 25%. But in general, we'll just leave it as a fraction unless we're told otherwise. So the probability of tossing a single die and getting one particular number is 1/6. Okay, there's 6 sides, so any one number is going to happen with the likelihood of 1/6 of the time. The probability of tossing 2 dice at a time is n over 36 because now I've got 36 possibilities. Looks like this. So the following table shows all the possible outcomes. So here's the first die, here's the second die, 1, 1, 1, 2, 1, 3, all the way up to 6, 6. So the probability of tossing a 6 and a 6, that's only can happen one time here, down here, out of the 36 possibilities. So it's 1/36. Well, let's find the probability for the experiment of tossing a 6-sided die twice, and the sum is 7. So the probability of the total toss of a total of 7, if I go to the previous slide, a total of 7 would be here: 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, 6. So that's exactly 7. So that happens 6 times out of 36 is 1/6. Probability and percentage. We talked about this a little bit. A survey was taken and commuters were asked what their average one-way commute time was in minutes. The following table shows their responses. What is the probability that a commuter selected at random has a commute of 20 to 44 minutes? The probability of a commute of 20 to 44 minutes, well, let's look. 20 to 24 is 16. 25 to 44 is 42. So we're going to add those two together, and it becomes 58 out of 100. Now, if we were asked to express it as a fraction, we could reduce that fraction. But if we're asked to represent it as a decimal, we could represent it as 0.58. Okay? So we don't reduce percentages. Typically, we will write them as decimals. So 0.58. All right, here's some notation that we've looked at before. When you need to count all possibilities of something occurring, when you cannot write out all the possibilities, we'll use permutations and combinations. Now, we looked at these formulas before. Again, these functions are on your calculator if you need to use those. Now remember that for permutations, it's used when order matters. The positions are distinct. So if I'm, putting together a baseball lineup, the different positions certainly do matter. Okay. Now, if I'm putting together a bowling team, then it probably doesn't matter what order the people are in. So that would be a combination. Okay. So probability with at least or no more than, well, these are going to be, things that sound like less than or equal to or less than or equal to. So we'll look at how we can represent those. When finding the probability of an event that includes the terms at least, at most, no more than, no less than, we must remember what that means. So at least 3 is probability 3, 4, all the way up to the probability of n happening. Okay? Another way to represent that would be 1, which is all possible outcomes, minus the probability of 0, probability of 1, or probability of 2 happening. So for this, we could use either one of these, whichever one was easier. At most 3 would be probability of 0 plus probability of 1 plus probability of 2 plus the probability of 3. Or we could write that as 1 minus the ones that are greater than 3, probability 4, probability 5, all the way up to probability of n. Okay, decide which one's easier to use, the one that has fewer calculations. All right, let's take a look at in-class practice 5 through 9 then. The percentage of the general population that has each blood type is shown in the following table. Determine the probability distribution associated with these. Probability of A is 0.41. Probability of B, blood type B, is 0.12. Probability of blood type AB is 0.03, representing 3 as a decimal, or 3% as a decimal. And then probability of O is 44%, which we would represent as 0.44. So if we added the population percentages together, that would equal 100. If we added the probabilities together, that would equal 1. Everybody has to have one of these blood types. All right, the arrival times of the 8 a.m. Boston-based commuter train is observed in the suburban town of Sharon over 120 weekdays and is summarized below. So the chance that it arrived 4 to 2 minutes early happened 4 times out of the 120. So 4 divided by 120 is equal to approximately 0.03. So about 3% of the time. Here I've got between 2 minutes early and on time happened 18 times. So 18 divided by 120 is 0.15. From on time, the 2 minutes late happened 50 times, which was 0.42 percentage of the time, so 42%. 2 minutes to 4 minutes late was 32 times. 32 out of the total of 120 equals 0.27. 4 to 6 minutes late happened 9 times. So 9 divided by 120 is 0.08. From 6 to 8 minutes late happened 4 times. So 4 divided by 120 is approximately 0.03. And from 8 to 10 minutes late happened 3 times. 3 divided by 120 also rounds to 0.03. These are actually slightly different, but they both round to 0.03. What is the probability that a person running for the 8 a.m. train will make it if they arrive after 8:02? So the probability of X being greater than 8:02 would be 32 plus 9 plus 4 plus 3 out of the 120 times, and they have about a 40% chance of catching the train. Find the probability that when drawing a card from a standard deck of 52 cards, you draw a queen. Well, the probability of the card being a queen, there's 4 queens out of the 52 cards. So your chances are 1 out of 13. Find the probability of rolling 2 dice and getting a sum that is odd. Well, the total number of ways to roll 2 dice is 36. 18 of them are odd, so that's going to reduce to 1/2. And that makes sense. Half the time it's going to be odd, half the time it's going to be even. Find the probability of rolling 2 dice and getting a sum not more than 6. Well, if I have the probability of less than 7, if I go to my chart of all the possibilities, 15 of them are going to be less than 7 out of the 36. That reduces to 5/12. So those are the things we had on the in-class worksheet. All right, so here is a chart of rolling dice that you might want to keep handy for the homework. So there is a WebAssign 9.7. There's not going to be a quiz or a test. Those dates have already passed anyway. So don't worry about it. There is no offloads 5. But do look at the textbook if you're having problems. There are some good examples. And on our class webpage under Chapter 9, there are some class videos, and there's also some example in the PowerPoint that came with the textbook. So if you want to look at those, feel free to do that. But that's where we're going to stop for today.